What can caves tell us about aliens? The summer after my sophomore year, I did cave research with Dr. Thomas and Dr. Oliveira, and we explored the diverse microbiological community that caves have, which are both stable and extreme environments. The mouth of the cave can contain photosynthetic bacteria, while the back of the cave tells us a lot about bacteria that do not need light. Why caves? Well, they have a relatively stable temperature. They're usually formed by hydrological processes, meaning they have water and they're damp. They have a diverse amount of bacteria, which are great for studying. And finally, we suspect that many caves on Mars are both useful for human and microorganisms. Looking at caves can model similar environments on other planets. Earth's two closest neighbors could in some ways be modeled by caves. For example, we know that Mars, pictured above, has caves, and Venus, pictured below, has had some recent discoveries that potentially could be modeled by organisms found in particularly extreme environments. This is a poster that I presented for Dr. Thomas and Dr. Oliveira over research we did. Right shows all the different bacteria that we discovered, some of which may be new species. Bacteria cultured range from photosynthetic bacteria to bacteria that consume iron as an energy source. And this shows the diverse cave environment. We could find life in our own solar system. We don't have to go far to start looking for life. Mars, Europa, a moon of Jupiter, Titan, a moon of Saturn, are all likely candidates. Venus is also a new candidate to add into the mix, given recent research. These are all pushing the field of astrobiology forward. Mars used to be wet and contain a more biologically friendly atmosphere. It's important to note that we cannot rule out that Mars could currently contain life or previously contained life. We know that there used to be water on ancient Mars. Two regions of note are Yellowknife Bay and Gale Crater. Left are pictures that NASA compiled of Europa. Right is what has been drawn by an artist. Europa is of note because it is made of an ice shell, and many kilometers under the ice is a liquid ocean. It's heated by the core of Europa as well as the tidal effect of Saturn's gravity. The artist depicts what is hypothesized eruptions of liquid from below the surface of Europa. Titan is similar to Europa. It has a liquid ocean underneath an icy core. What's interesting to note is that there are rains of hydrocarbons. An example is top right, and methane ponds on the surface, pictured bottom right. There are bacteria on Earth that can use methane as their primary carbon source. What kind of life will we find? We most likely will not find Spock, ET, or Yoda. However, we are likely to find prokaryotes, or in other words, bacteria. We don't know that intelligence or multicellular life have strong selective pressures in evolution, so it's unlikely we'll find something like us. We live in a bacterial world. Bacteria are the most successful organisms on the planet. 38% of our own genome matches with genes in bacteria. There are more bacteria on our skin than there are humans in the world. And in terms of numbers, longevity, in terms of their survival, and ubiquity regardless of environment, bacteria are the rulers of the planet. There are bacteria living in extreme conditions on Earth. On the left, we have a hot spring at Yellowstone. The different colors you see are made by bacteria in near boiling water. On the right, the orangish sludge that we see is produced by bacteria that metabolize iron. Interesting to think about when we know that iron is a common resource on the Martian surface. We should not forget about viruses as well. We suspect that viruses could have evolved before bacteria on Earth. While viruses are not considered living by many biologists, indubitably they have been one of the driving forces of evolution on Earth. They can also, quote unquote, survive in extreme environments. There are many common misconceptions about what is required for life. As depicted by SpongeBob, life on Earth does need water, but it has been put forth that other molecules could be used as a solvent for some biological reactions instead of water. However, with what we currently know, water is our best chance at finding life. Another misconception is that we only know of one kind of biochemistry. For example, some have stated that silicon can replace carbon. That's also unlikely. However, silicon could be used in a different way by organisms as a kind of structural support in some molecules in exotic environments that have a lot of acid. Another common misconception that us Earthlings have is that you need oxygen to grow. Anaerobic bacteria don't require oxygen at all for growth. They are bacteria that lives deep in soils, and this is another place on other planets that we could look for life. The quest for finding other life has driven us to new scientific and technological breakthroughs, inspires our popular culture, and forces us to ask broad philosophical questions about our place in the universe. Research in this field pushes us forward more than just scientifically, and this is exampled by the Martian and both of the Apollo mission, all the Apollo missions. Science fiction can inspire research. One of the papers I researched literally discussed how this episode of Star Trek, The Devil in the Dark, inspired their research. Not only does science push our culture forwards, sometimes culture can have an influence on what we research. This was the Silicon paper. This is a photo of the Mars rover Curiosity taking a selfie. Once again, we see how culture plays a role in science. We have recently sent another rover, Perseverance, to look for evidence of life on Mars. This is a new and exciting field. The moon is also important. This is a picture of the surface of the moon, and it can tell us a lot about the early Earth. It could potentially give us a launching port for manned missions to Mars. Future lunar research could give us more insight into the composition of early Earth and how it shielded us from early asteroids. Venus became a promising candidate for future research this year. Phosphine has been recently discovered on Venus, and microbes on Earth are responsible for a majority of the phosphine production. The surface of Venus may be hot enough to melt lead, but the clouds of Venus could provide a haven for life. Above are my 2 emails if you want to reach out and contact me, and my sources. On the left is my bibliography and a lot of the literature that I consulted, and on the right are hyperlinks to all my images. Thank you.